Hello everyone. At our next video for the P5 section. This section we're going to talk about how to work with algebraic expressions. Hopefully it's a review for everybody, and that you don't have to think too hard on this section. Hopefully it will give you a little bit of practice to get back in gear working with these things. So when we're talking about algebraic expressions, usually what we mean is something like this. So like with 5x plus 7. So this represents a number, depending on what value of x we use. But it's not an equation because we don't have an equal sign there. And it's not just one thing that we could just call a number, so we call it an algebraic expression. Another one of these, just to see a couple, they're not always two terms. Talk about what the terms mean more next time. And so there's another one. So all we mean when we talk about an algebraic expression is we have some type of expression where we have a variable involved, and we might have more than one variable in there, and then the different terms. We'll define a term next time that we're putting together with plus signs and minus signs. Get algebraic expressions from that. The main thing we want to do here is we want to be able to do operations with algebraic expressions. So we want to be able to add, subtract, and multiply. Is what we're after in this section. So again, hopefully it's review, but maybe it'll be a good refresher for you. So here we got two algebraic expressions, and our instructions tell us we want to add these two. Okay. Since we're adding, we got a plus sign in the middle. Okay. This is what we get. So with addition, if we're adding algebraic expressions, we really don't need these parentheses. Okay, so if you don't like them, if you're just adding, you don't have to have the parentheses. But really all we're doing here when we're adding is we are going to, probably what you might know is combining like terms. Right? So any term where we have the same variable in it, we can combine those. So like this one, we have x term and an x term here. We can combine those. It's a positive 6x plus a 3x. So if we combine those, we just add the coefficients together. Variable stays the same, we get 9x. We have two more like terms. We have minus 3 with no variable plus 8 with no variable, what we would call a constant term. So there we have negative 3 plus 8. Careful with your signs, and we get plus 5. So that's get there. So adding algebraic expressions is really just combining like terms. So that's really short rundown on that one. And one that we might think about a little bit harder is if we're going to subtract. So if we're going to subtract algebraic expressions, so what would that look like? It would look almost the same, except in between the algebraic expressions we'll have a minus sign. Subtraction. So get one. So minus x squared minus 6x plus 4. Okay. With subtraction, we do need the parentheses. The reason why we need parentheses is because what this is telling us that we want to subtract. And what part of this do we want to subtract? We want to subtract everything in the parentheses. Not just the first term, we're going to subtract that whole thing from 8 minus 8x. So if we're going to do that, then one of the easier ways to think about it is to think about the minus sign up front, and it's going to change the sign for every other term inside the parentheses. Right, so let's rewrite it, but we're going to switch all of those signs to do our subtraction. So I'm going to drop the parentheses on the first one. So we'll have 8 minus 8x. And now what are our signs going to be? We're going to have minus x squared. It was positive, now it's negative. Then we did have a negative 6x. So now it's going to be plus 6x. Then we have a plus 4, but with the minus sign changes that to minus 4. Then once we've done that, once we've distributed that sign, it's just like the last problem. We just combine like terms. So let's look and see what like terms we have. What stands out to me is we have an x squared term, and this is our only one. And so we don't have anything to combine it with. So I'm going to write it down, negative x squared. Okay. And then if I go down kind of in order, we'll talk about the order next time too. But here we've got negative 8x plus 6x, two x terms. So when we combine those, negative 8 plus 6 is negative 2x. Then we've got the no variable terms, or the constant terms. There we have positive 8 minus 4. 8 minus 4 leaves us with a positive 4. So subtraction's not much harder. Okay, it does have the one more important step. Okay, remember to distribute these signs. Distribute the minus sign to everything in the second term. If you forget that, you're really going to mess up. Okay, you're going to get an answer that's way wrong a lot of times. So make sure you remember, if it's subtraction, you have that minus sign in between. You have to change the sign of every term in the second algebraic expression. Alright, and then the last operation we want to be able to do, that we want to review, is when we multiply. How do we multiply these? This can look a few different ways. Okay, so we could have some really small algebraic expressions that we multiply. So maybe we just have something like 2x squared times x. So then how would we do that? If we don't have any plus signs or any minus signs in there. So what we do is we take the coefficients and multiply those together. Here we have a 2. This is a 1. So 2 times 1 give us 2. Then we multiply the variable parts together. So we have x squared times x. We talked about that last time. X squared times x. We add the exponents, 2 plus 1, so we'll get x to the third. 2x to the third. Sometimes we do have algebraic expressions with more than one term we want to multiply, so that look like. So maybe we have 2x to the third times, add a parenthesis there for multiplication, x minus 3. Alright, so this might ring a bell. This might remind you of something we're going to use here called the distributive property. And we've kind of already used it when we distributed our negative sign. Here it's a little more explicit. Okay, so what we're going to do is we're going to take the term out front. We're going to multiply it by the first term inside our parentheses. Then we're going to multiply it by the second term that's in our parentheses. 2 steps here. So if we do 2x to the third times x, give us 2x to the fourth. We add the exponents. Now we got to finish. We got to multiply times the other term. So 2x to the third times negative 3. 2 times negative 3 is negative 6. Having x to the third term there. Sometimes we need to use the distributive property. Just remember, when you're multiplying, you add the exponents. Okay, and then one other really common way you'll see these. Maybe we have 2 algebraic expressions with more than one term. So something like 3x minus 1 times x plus 2. Again, this might ring a bell, something you talked about before. A lot of times we call this type of multiplication the FOIL method. Get it right. Method. And here FOIL just tells us, just helps us not forget any of the distributions we're doing. So we're going to multiply the first terms together, these two. We're going to do the outer terms together. That would be these two. Then we're going to do the inner terms together, these two. And then we're going to do the last terms together, these two. It doesn't really matter that you do them in that order. What matters is that you do all four of those. In a case like this, you do all the multiplications. So we will do them in first, outer, inner, last order, though, just to help us be able to follow along. Okay, so let's do that. So our first term is 3x times x is 3x squared. Our outer terms, 3x times 2, gives us a positive 6x. Our inner terms, negative 1 times x, that gives us negative x. And our last terms, negative 1 times 2, gives us negative 2. Hopefully you notice something here. That is that we have like terms, middle, that we can combine. 3x squared stays, but then we have 6x minus x plus 5x. And minus 2 doesn't have a partner. It stays. 3x squared plus 5x minus 2. And FOIL method, really all it is its distributive property. So for distributive property, we would take the first term and multiply it by both of the terms. Second one, then we would take the second term and multiply it by both of the terms in the second one. Okay, but we call it FOIL just because it gives us a little mnemonic to not forget any of those. Okay, but FOIL method distributive property is really the same thing. Alright, so that should get you through section P5. Work on factoring later this week. Let me know if you have any questions.